Good evening and a warm welcome to the SCS Fireproofing series on the topic International Trends and Best Practices in PFP and Intumescent Coatings. I take this opportunity to introduce our speakers and moderators. Let me first introduce our moderators for today. Mr. Anand Basal, Regional Project Director, DLF Limited. Mr. Anand is a senior project management professional in real estate and constructions and design development. A well-qualified and self-driven individual, expertise in the overall process for project design development to project delivery, residential, commercial, detailed, and mixed-use projects. He has worked with reputed organizations like Prestige Constructions at Bangalore, K. Raheja Corporation, MRMGF Land, PT and Puravankara Limited. Our next moderator is Mr. Anil Agarwal, Assistant Professor, IIT Hyderabad. Dr. Agarwal is an Assistant Professor in the Department of Civil Engineering at IIT Hyderabad. His research interests include behavior and design of structures under fire conditions and other extreme events such as blast and earthquakes. He has more than 10 years of experience of investigating and analyzing the behavior of structural systems under extreme loading conditions. Now our speakers from Hempel, Mr. Scott Fretwell, Group Business Development Manager, Cellulosic Fire Protection. Starting with one of the largest steel fabricators, structural engineers in the UK, Mr. Scott has worked through purchasing, production, and estimating to sales and key account management with a major global paint manufacturer. Then as a sales director, managing an off-site shot blasting and painting contractor. For the last 7 years, his main focus is cellulosic fire protection market, and he is currently the Group Business Development Manager for cellulosic fire protection for Hempel. Up next, Mr. David Barron, Subject Matter Expert Fire Engineering, a chartered structure in fire engineer with 12 years experience with the emphasis on steel design using various global design trends. Now leading a global team responsible for fire engineering and estimation of intumescent coatings for Hempel. Up next, Mr. Roger Solar, Group Product Management, Cellulosic PFP, chemist with 13 years of experience in coatings and construction industries, starting from technical roles to project management, now managing the product portfolio and leading the development of new cellulosic intumescent PFP coatings to meet customer needs. Up next, Mr. Eric Van Schajvik, Subject Matter Expert, Passive Fire Protection, a BSc in Civil Chemical Engineering. He started in protective coating industry 23 years ago. After gaining experience of all types of protective coatings, he specialized since 2002 in the field of passive fire protection. His experience lies in formulation, development, testing, and certification of intumescent coating systems with global scope. Day to day, he provides technical advice and training on the correct use of PFP, and obtains and maintains PFP approvals and certificates for Hempel's intumescent products. Up next, Mr. Tarun Kumar S., Senior Sales Account Manager, Passive Fire Protection and Protective Coatings. Tarun is a management and engineering graduate with about 10 years of experience into B2B sales of industrial product lines. After gaining experience of industrial sales, he specialized since 2014 in the field of protective coatings and passive fire protection. His expertise lies in solution providing skills more than selling a product job. Requesting all the attendees to please participate in the poll and do write the name of the speaker whom you would like to address the question to during the Q&A session. Also glance through our latest interactive issue, SSMB magazine, the link to which will be available in the chat box. Also do subscribe to our YouTube channel, SCS TV, where we are live now and when you can get all steel construction updates. Before we move on to the session, I request Carol to make a short announcement.
Thank you so much, Andrea. Good evening, everyone. Before we move on to the exciting discussion for today, I would like to make an announcement about upcoming panel discussion in the sector, which is very much booming, and we look forward to the boost of the industry, which is the warehousing industry. The topic for the discussion would be a new age sustainable design versus standardized design in warehousing industry. The discussion would focus on specific designs, innovation in the construction system, planning and design efficiency, sustainability in the overall project. The entire discussion would have a keynote address by Mr. Anshul Singhal, Managing Director of Wealth Fund 1, with Ruchi Panwar being the moderator for this session, along with 7 panelists from Wealth Fund 1, Indospace, Coolx, Chain Limited, Everest Industries, Coin Consulting, RSP, and KSH Infra. So do join us next week on 14th October at 4:30 p.m. for a panel discussion. The link for the same is in your chat box. Register now. Thank you so much. Over to you, Mr. Scott.
Thank you and good day, everybody. My name is Scott Fretwell. I am Group Business Development Manager for Passive Fire Protection at Hempel Paints. And I thank you for joining our webinar today on passive fire protection and intumescent coatings. On the first part of the presentation today, I'll be taking you through a brief introduction of Hempel Paints, some details regarding our R&D Passive Fire Protection Centre of Excellence, and some basic fundamentals of passive fire protection. Then I will pass on to my colleagues who will take you through the rest of the presentation today on calculating thicknesses of fire protection, fire design, Hempel engineering estimation, and the introduction to Hempel cellulosic PFP. If you do have any questions on today's presentations, please feel free to use the text box, as we have some of our CPFP technical colleagues on hand to answer any questions you may have. So Hempel Paints, who are we? Hempel are a company with over 100 years of coating experience and able to offer a wide range of protective coatings to suit all requirements. From specialist coatings enabling fast steel production, to environmentally friendly paints and to passive fire protection solutions. Whatever your requirements, Hempel will have you protected. Now, and has been for many years, a lot of our coatings are protecting a variety of man-made structures from the corrosive forces of nature across the world. And as you can see from the map on screen, our footprint of 28 factories, over 150 stock points, and 15 R&D centres across the world enable us to be a true supplier and supporter of protective coatings. With over 6,500 employees operating in over 80 countries, this really provides the basis of our support for all our business and customers across the globe. We also have our global network of more than 700 certified coating advisors. With this, we're able to support your coating processes, specifications, and maintenance procedures to ensure the full utilization of your time and resources during coating applications. For fire protection, at the heart of this is our R&D PFP Centre of Excellence facility. In 2018, we inaugurated our Centre of Excellence in Barcelona, Spain, which was purpose-built with one focus in mind: for passive fire protection. This state-of-the-art facility comprises over 3,000 meters square of laboratory space and is home to many highly skilled professionals such as technicians, scientists, applicators, fire testers, engineers, all dedicated to the development of fire protection. So why do we do this? Why do we build this? Well, a few reasons. With state-of-the-art fire testing equipment, because of product innovation. For a world-class product development and to also provide a base for our business technical expertise function, which enables us to further support our current fire protection products and customers with technical advice, estimations, and fire designs around the world. It's our ambition at Hempel to become world leaders in passive fire protection, and the building of this facility was the start of this journey. So when we talk about passive fire protection, or PFP, what do we mean? Well, it's really important to note that there are two distinct fire types, and these have very different solutions: cellulosic fires and hydrocarbon fires. The main differences between the two fire types, as you can see on screen, are the fuel source or the combustible materials, and also regarding fire, a time v temperature scenario. Cellulosic fires traditionally consist of wood, paper, and textiles, generally found in civil construction, whereas hydrocarbon fires consist of oil and gas fuels, usually found in refineries and oil platform type scenarios. Regarding the fire time v temperature, to the graph on the right-hand side of the screen, you can see here an example of the cellulosic fire curve in red. And you can see straight away, it's a more gradual fire curve. And it takes longer to achieve its maximum temperature, which is around 1100 degrees C in 2 hours. Whereas the hydrocarbon curve in orange achieves their maximum temperature much quicker, maybe 1100 degrees in 10 to 15 minutes, then maintains it for a given period of time. You can see from the two graphs that the cellulosic curve is less onerous, and this is the fire type we will be discussing and concentrating on today. So, why do we protect steel from fire? Like all construction materials, steel will lose its strength at elevated temperatures. To represent this on screen, you will see an indicative graph which represents how structural steelwork can lose its strength at elevated temperatures. You will see on the right of the graph the strength retention. One is a steel retaining 100% of its strength down to 0. And horizontally across the bottom, the steel temperature. So we start off at ambient temperature, a room temperature, around about 20 degrees C. And we can see from the icon on the right, the steel retains 100% of its strength. However, if there was a fire, we can see around about 550 degrees C, the steel profile would have lost around 40% of its strength. If the steel continues to increase in temperature, in this case here we have 630 degrees C, you can see now it would have lost around 60% of its strength. And if we continue that rate of steel temperature increase to 725 degrees C, it's now lost almost all its strength. It's lost 80% of its strength. And depending on the load being applied to the steelwork, you can see at some point that this steel profile will not be able to support the applied load, and then we have the serious possibility of structural failure. So why do we protect from fire? Why do we want to prevent this from happening? Well, the temperature rise needs to be prevented so that the building can maintain its structural integrity in case of a fire. This will enable safe evacuation of people in the building and also provide access and time for emergency responders to fulfill their roles without fear of building collapse. If you would imagine a large multi-story building, and we take the picture on the right, if you were situated on the top floor and there happened to be a fire on the first or ground floor, you would hope and expect to be able to evacuate the building in good time and without fear of building collapse. Another factor is asset protection. Buildings, as we know, are very expensive, and replacing the building every time there was a fire would not be sustainable. So protecting the building and the building's assets are equally very important. And finally, there is legislation, a legal requirement to maintain these structures for a given period of time. And this is usually in accordance with local, national, international building codes. So what is an intumescent coating? This is a reactive coating which resembles, in a normal day, a decorative system. And when once applied, will lie dormant on the steelwork. However, in the event of a fire or exposure to heat, the coating will expand to form a low thermal conductivity char, which slows down the temperature rise of the steel to protect the steelwork for a given period of time. Traditionally, intumescent coatings consist of binder, catalyst, carbon source, and blowing agent. And later in my presentation, I will present you a video to show the reaction process. And as you can see from the image here, the intumescent coating generally expands to around about 50 times its original dry film thickness to form that insulation char. So if we apply a millimeter, this char will expand to 50 millimeters, protecting the steelwork. So Intumescent coatings, what do? In short, here we see the standard cellulosic fire curve we presented earlier. In the event of a fire and the steel was unprotected, it would reach its critical temperature within 10 to 15 minutes, which clearly would not be sufficient for building evacuation, for any safe access for emergency services, or provide any protection to the building or its contents. By protecting the steel with an intumescent coating, you can now see we're able to provide thermal protection to the steel for a longer given duration of time. Again, these duration of time will be dedicated or dictated through by local, national, international building codes. I am now pleased to hand over to my colleague, David Barron, who will take into more detail on how we calculate thickness of fire protection, fire design, and our engineering and estimating functions. Thank you, David.
Thank you, Scott. I shall just share the presentation. I hope that you can all see the screen, and thank you, Scott, for handing over and presenting on the fundamentals of passive fire protection. And I hope you are all doing well in these extraordinary times that we live in. My name is David Barron. I am a structural fire engineer, and it is my pleasure to now take you through how we actually calculate the thicknesses of passive fire protection. So one of the things we've been talking about is that steel is a very versatile construction material used globally. It enables for very sustainable structures to be constructed in a very fast and efficient way. But like all materials, as Scott had mentioned, they lose their properties at elevated temperatures. And we need to be able to provide protection to these elements. And one of those ways is to apply an intumescent coating. But what actually goes into calculating the thickness of an intumescent? And I believe one of the questions already asked was, how do we actually estimate the amount of coating required? Well, it's a very complex process to actually derive the thicknesses required for steel. In the event of a fire, there are three major parameters that we need to be able to calculate the thickness of an intumescent coating. One of these parameters is known as a section factor. This is related to the steel geometry and the actual steel sizes used within the construction. The next is the fire duration. How long does the building need to maintain its structural stability? And the third parameter that we need is the critical temperature. At what temperature does the steel be deemed to have failed under the fire condition? And once you have these three parameters, you are able to then calculate a dry film thickness of intumescent. And I would now like to go through these three parameters in a little bit more detail with you. The first parameter is the section factor. And this has many different names depending on where you are globally, but they all refer to the same thing. We've got section factor A over V, HP over A, and it all refers to how much of the steel element is actually exposed to fire and how stocky or chunky that section is. So the higher the stockier a section is and the lower the heated perimeter, the slower that profile will heat up. And I have two examples in the slide to show how this would look. On the far left, we have a very slender and light section. So a very, very high heated perimeter. So a large surface area exposed to the fire, but doesn't have much steel mass. In this instance, that profile will heat up very quickly and effectively need a higher thickness of intumescent. The profile to the right, you can see, is a much, much stockier section. So it has a lower cross-sectional area that is exposed to the fire. And also it has a very, very high nocivity. It has a lot of steel in that profile. And this profile will heat up a lot slower in the event of a fire, and as such would require a lower thickness of intumescent. And this concept, as I said, is known as section factor, and a key parameter in calculating thicknesses of intumescent. The next parameter that we need to be able to calculate the thickness is, well, how long does the building need to maintain its structural stability? And this is often given in terms of a fire resistance period in minutes, 15, 30, 45, 90, 120 minutes. And these are usually derived from local legislation or sometimes international standards, and are usually decided upon depending on the height of the building, the occupants within the building, and other variables such as that to determine how long that building needs to maintain its structural stability, so that people can escape, emergency responders can deal with the blaze, and ultimately save the building from the effects of fire and ensure that that building can be reused after a fire. And the third and final parameter that we need is something known as critical or limiting steel temperature. And this was another one of those key parameters that Scott had mentioned in his slides. At what temperature does the steel be deemed to have failed under fire conditions? And as manufacturers, there are prescriptive limiting temperatures that we can adopt if we know nothing about the structural use of that building. In the USA, these temperatures are usually 538 degrees C for columns and 593 degrees C for beams with a concrete slab on the top. In the UK, Middle East, India, and New Zealand, we typically find that those temperatures that are prescribed are 550 degrees for columns and 620 for beams. And in Europe, we tend to find that the temperatures are around 500 to 550 degrees, depending on which country you are in. And these temperatures actually come from the design codes that are typically used for construction. And one part I'm going to discuss with you in a little bit more detail, or at a very high level still, is how you can actually calculate these temperatures using fire design concepts and actually looking at the applied structural loads within buildings. But to put this all together, I have here an example of one of our products, Hempifire Optima 500. And we test all of our products at third-party and certified laboratories to essentially build what's known as a multi-temperature assessment. And this has parameters such as the temperature I mentioned, the section factor, and the duration. And this is an example of the sort of data that we get from these third-party laboratories. So if you had a project, and for example, say it was 120 minutes fire duration, we knew that we had a steel column that had a section factor of 80, and a limiting temperature prescriptively of 550, we would simply turn to the correct page in the assessment. So in this case, 550 degrees. We would be able to then read off from the fire duration, 120 minutes, and then finally read off from the section factor. So for this example, the thickness of intumescent we would require for that one profile on that project is 1.464 millimeters. If the section had been lighter, the DFT would be bigger. If the section had been more stocky and a lower section factor, then the DFT would have been smaller. But this is how we derive the thicknesses for projects. So that is the fundamentals behind what estimation looks like for fire protection. And one of the things I wanted to cover here was a little bit about what an engineered approach might look like. So rather than taking a prescriptive route, seeing if we can actually optimize the fire protection requirement on these structures through fire design. And first of all, well, what is fire design? Well, the slides we saw before, we have three main variables that we need as manufacturers or as designers to calculate the thickness of intumescent coatings. One parameter, as I said, section factor, the other fire duration, and the other one is this concept of limiting temperature. Now, quite often, the steel sizes have already been designed by the structural engineers, and possibly they have already been fabricated or even installed. So there's sometimes not much of an opportunity to modify these sizes. The fire duration, again, this is derived from local legislation and based on the occupancy and height of the building typically. And again, this is very difficult to change unless you look at a real fire engineered solution, looking at the fire loads within the building, the ventilation conditions, and actually start looking at it from a real fire perspective. But again, not something that is typically done or that would take a long time to be able to do. But really, the one parameter I want to discuss with you today is this concept of limiting temperature. As I said earlier, this is something that we go off prescriptive values within the industry. And as manufacturers and as designers, if we do not know anything about the structure, we should be defaulting to these values. But these prescriptive values were created by the industry quite a number of years ago to ensure that a robust level of PFP, or passive fire protection, are applied onto structures. But this means that inherently these temperatures that were selected in many cases can be quite conservative. And the reason for this is they were meant to be a catch-all, so that any structural type or any structure type would be protected adequately. But ultimately, fire design allows you to actually calculate these failure temperatures in the steel elements based on the applied structural loads. And this is all within the design codes, codes such as BS 5950 and the Euro codes, and even the Indian design codes have a fire part within those codes to be able to optimize the fire protection requirement, looking at the structural stability and the actual loads applied. This enables fire engineers and structural engineers to balance the various factors, such as the composite action within the structural frame, the loading factors, and the end use of the structure and the occupancy type, to be able to calculate these temperatures, which can differ significantly from the prescriptive ones I showed earlier. And the key to unlocking this sort of approach in fire design is to start looking at the structures in terms of something called utilization, or more specifically, the accidental limit state in fire. And these prescriptive limiting temperatures I showed you earlier, the 620 and 550, are all based on the assumption that steel is fully stressed at normal temperature design, 100% utilization. And the utilization actually refers to how much of the capacity of steel is being used. And I've got a image of how this looks. So if I was an engineer and I have a steel beam, for example, I may load this up to 100% of its capacity or 100% utilization in normal working life. And if I could apply no further load to that without that beam failing, I would class that as 100% utilization. But engineers typically like to sleep at night. We don't often design all our buildings to be at 100% utilization. There may be some elements within a structure that are at this level of utilization, but more often than not, you tend to find there's a variation between 100% all the way down to 0% for your more minor tertiary sections. So typically there is a range of utilizations, but very often it's not at 100%. But more importantly, when we talk about fire under the design codes, including BS 5950, Euro codes, and the Indian design codes, there is a load combination for the fire limit state. And what this enables you to do is actually lower the utilization in the fire limit state, or the accidental limit state for fire. This is because you don't expect there to be as much live load in the building, and you don't expect the dead load to be increased either. So you actually have different load combinations to reduce the utilization in fire. This is all well documented within the codes. But what does this mean? Well, one of the first slides you were shown in the presentation was this concept that steel loses temperature at elevated temperatures. And on the left axis here, I have the strength retention again. And on the bottom axis, the temperature within the steel. So as a designer or as a manufacturer, if we know nothing about the structure, we would assume 100% utilization and default to the prescriptive limiting temperatures. So in this case, 550. And please note that these values I'm showing are indicative, just to sort of show at a high level the sort of concepts behind the fire design approach. But if I was told by the structural engineers that the structure actually wasn't loaded beyond 80% of its utilization, the design temperature would be higher. This is because there is more capacity left within the steel. So you can allow the steel to get a bit hotter. And again, if the steel was only stressed to 60% of its utilization, again, the design temperature would increase because of that extra capacity within the steel. And why is this important? Well, as we mentioned in one of the first slides on the estimation approach, if we know nothing about the structure, we would default to 550 degrees and provide a DFT depending on the steel size, maybe 2 millimeters in this example. But as soon as we start looking at in terms of a fire design approach and actually starting to look at the structural response or the utilization within steel, something will happen. If we were told that the steel is at 100%, then we would expect the answer to be the same as the prescriptive limiting temperature, because that's where it comes from. But as the utilization drops, or there's more capacity within the steel, you can see that the thicknesses required on projects or on those steel elements actually decreases. So for 80% utilization, you might see a 14% reduction in thickness and then associated volume for that profile. And again, if you have very light tertiary elements that might not be doing much in the fire limit state, might even have reductions of 40% for down at 20. And the key takeaway here is the lower the level of utilization within a structure, the higher the design temperature, and thus the lower the dry film thickness of intumescent. And this, using fire design can bring many added benefits to projects. First of all, there is a clear potential to reduce the overall volume required on a project. But also, along with that, you also get application enhancements as well. You do not need to apply as many coats, so the labor costs and time to actually complete projects also reduces. And also something that's also very important going forwards in the built environment is sustainability. If there are less chemical processes, less paint, and less labor on projects, there is sustainability benefits as well from doing these kind of fire design assessments on projects to optimize the fire protection requirement. And Hempel very much want to work on key projects and work with design teams to look at actually optimizing the thicknesses through fire design and actually becoming part of the design process to make sure that the steel part and the fire protection part are considered holistically and combined to make the most efficient systems for both steel and fire protection. And I only have one more slide before I hand over to my colleague Roger. I just wanted to briefly go a bit about Hempel's estimation and engineering function. Now, what we've been discussing here is how we calculate thicknesses and how things can be engineered. But Hempel have been investing heavily in our competencies. That is our people, our engineers, our estimators, and our designers, and our coating experts, and to be able to give the best solutions on projects globally. And we have spent a lot of time building teams through Europe, Middle East, Southeast Asia, and to be able to provide this globally and to be able to provide the best estimations and, where possible, fire design assessments on projects. But not only have we investing in the people, we've also been investing in the software to enable us to be more efficient and actually provide you with the most accurate thicknesses for your projects, depending on all the parameters we discussed before. And along with what my colleague Scott had mentioned before, tie this in with the fact we have opened a new state-of-the-art laboratory in Barcelona and our global footprint. I think you can see that we are committed to becoming leaders in passive fire protection. And we very much welcome working with you all on your projects at whatever stage you are within your projects, at design or actually at construction, and even after during maintenance. So I would like to thank you all for your time. I would now like to hand over to my colleague, Mr. Roger, and thank you.
Thank you, David. Thanks, everybody, for coming today. Do you see my screen?
Yes, sir.
Okay, good. And also the camera. Yes, sorry. Good. Perfect. Good. So, okay, so I'm Roger Soler. I'm based in Barcelona. I'm the responsible of this fire protection products for cellulosic fire protection. So let's go. So protecting steel for us, Hempel, we started protecting the products from corrosion more than 100 years ago. And then we moved also to protecting from fire. No? As the buildings that have different parts with different roles, no? Like the foundation, the structure, or the roof, in the coating systems, it's a little bit the same approach. There is a primer that ensures the adhesion of the system to the substrate, like a foundation, in the cold state, so in normal conditions, but also in the fire conditions, what we call stickability, that will allow the char to be there working. And finally, also providing the anti-corrosion properties to make also sure that the product will last for a long time. The Intumescent, it's protecting from fire, as my colleagues already explained. It's expanding and giving the right time. And then there is the top coat. It's the roof of the system that it's providing an aesthetic color function, providing the color and the desired finish, but also it's the sealer function to prevent the early degradation and the inactivation of the intumescent layer in the case that there is the service conditions are severe. So then that could be a attack from strong weather elements. Protecting the steel from corrosion and from fire, it will need that it's durable in these weather conditions for a long time. And we will be testing then, in our case, the protection of the steel. We always look in two ways. One is the steel corrosion. So really, we do all the standard tests that could be done in an offshore platform in the middle of the ocean. And then also we do the specific tests for the intumescent paints to make sure that there is no intumescent degradation, that there are also different international standards. It's important that it's a compatible system, that it's really like a glove to the hand, because we need this compatibility. At the end, we want to limit the risk that there is in the fire protection. And the point is that if we are using a wrong primer or a top coat, at the end, it's not like in the standard corrosion projects that we normally find. So it's not just that there is corrosion, or even if it is a tongue lining, that then there could be contamination of the food inside there. In the case of a PFP, if there is a fire, then it is a potential loss of fire. And it doesn't allow us to put it in the plant maintenance. When there is a fire, everything needs to work properly. So here in the right, you see the pictures. These are steel sections tested in our furnaces, where we have checked if there is a good adhesion or there is a bad adhesion. This is simulating a three-sided beam. Here you can see the web and the flanges, and those lines here are the thermocouples that we install to check the temperature during the experiment. And on the top, it worked. So the char developed. It produced this white char that it's doing these insulation properties, while on the bottom, there is a primer that it looked okay in the cold state, we call. So there is a good adhesion in normal conditions for a paint. But when it comes to fire, then the whole system just falls out. When it's falling, the char, then what it's exposed to the steel, and then there could be an intake of heat much higher than it is desired. So the building would collapse sooner. So that's why that when there is a system of specified, it's not just separate pieces, that we need that it is a compatible primer, and then also the same for top coats. So there are very demanding conditions during the life of the building, depending on what it is, the exposure, like humidity, ultraviolet rays, temperature changes, and then the ceiling, it will depend on the type of top coat that we are using. And it's important to select the right one in order that they behave in the same way, for instance, to the thermal expansion and contractions. Here I'm showing a picture of a sample of a system that it has the same thermal expansion and behavior. So after the exposure, there are no cracks. And when we test them into fire, there is a normal expansion. But some systems might not be compatible once they've been exposed to this aging. So there might be cracking, for instance. And then through this cracking, the humidity could penetrate to the intumescent layer, and depending on the type of intumescent paint used, it could be not resistant to that paint, or at least reduce the intumescence level, so the expansion properties would be lost. So again, this would be a failure then to protect the steel structure. So this protecting the steel and considering the different type of environments and how it needs to be done. Indeed, recently in LinkedIn, we have published a white paper for cellulosic fire protection. So you can take a look there, or reach our colleagues also, reach us in order that we can better explain you the things and solve the doubts that you might have. If fire protection is done with the right calculations, the right estimations, and with the right systems, then the result is what we see here. This is a building that was protected with our systems, and we received a phone call asking us, how do we do to repaint the building? And it was a building that it was protected for 60-minute fire duration, and the firemen took more than 3 hours to extinguish the fire because of the difficult geography of the Azores Islands. They are in the middle of the Atlantic Ocean, and the building, the structure, it resisted. So the coating worked properly. The owner of the building indeed was very happy. So we have a case story on that. And the fire department, indeed, they gave the acknowledgement to the fire protection, that it helped the structure to resist that blaze. We have other buildings where there has been a fire, but our customers wanted to keep their privacy. So we respect, but this is a very big building in the Middle East that had a fire, as you can see by the size of the steel structures, and it also resisted and prevented the building to be collapsed. So they also cleaned, gave the right roughness to the steel, blasting when it was possible, and then also using other media to provide the right roughness of the surface, and then put again primer, intumescent, and top coats to make it work. So we trust our products. We test them, but also we have seen them working. So we trust that also our buildings, we protect them. So this is our new R&D facilities in Denmark that are being protected with our products. We are doing also buildings for the other customers. So we have different type of buildings and in many different countries. So this is an example in Oman of a hospital. But we have also many Porsche shopping exhibition centers in Germany, where the customer precisely like the productivity and also the appearance of the system. We have also our coatings in hangars, in the airports. Also, in the Lachta Tower in St. Petersburg, the headquarters of Gazprom, that the building that we were saying before. So it's in the top part of the building. It was asked also to use our products. We have these other examples of airports. For instance, these trusses in the Czech Republic airport. Stadiums, closed ones, also open ones. So we have all type of buildings, also all type of projects. This is a restoration of a hotel. So one of the key drivers of the project was to reduce the time that the painting, the refurbishment process could take. And PFP part, it was a fraction of that we could contribute to reduce that. And also in India, that we started now coming to India, and even despite the COVID, but we have already been awarded to several projects. This is the Centauros IT Center here in Hyderabad. So as soon as COVID is allowing us to continue, this is being painted. No? And many more. So in the case that you need more references, just let us know. Get in touch with our with your sales representative or your contacts in Hempel, because we have done many type of products, and also in many type of different conditions, from the north of Europe to the warm and dry conditions of Qatar or Saudi Arabia, and also in warm and humid conditions like the ones that we find in Southeast Asia. So this is how we are approaching, and a bit also the product range that we have and the benefits that can provide to architects and specifiers. I will not enter into a lot of details of our products. Our sales representatives can also help you on that, but just to mention that we have also products that can help for any fire duration that you might have. So from half an hour to 2-hour fire protection, that it is commonly found in also here, for instance, here in India, that we've seen most of the buildings for 2 hours. And then also we have available 2 different technologies, waterborne products, that then they are most suited for the on-site applications, and that they can provide protection for semi-exposed conditions or in the interior of the buildings, and to conditions up to a C3 interior. So that could be even quite demanding parts like kitchens, or even the swimming pool areas, or areas where it is with a relatively high content of humidity always. And for the more demanding environments, we have solvent-borne products, and here we offer indeed 2 different products in order to provide the optimized solution really for these 2 different fire durations, because at the end the thicknesses that might be required then it's a way to optimize the project and to make it at a lower cost, with a higher durability, and also with a higher efficiency in the building process. Those products have different standards according to the different regulations. Here we're showing the major ones that could be applicable. So the BS standard used in the UK and also in many countries like in India, and then also the European standard that it's also widely accepted in many parts of the world. But then we have also other approvals for other countries like in Russia, China, and now coming to Australia and Chile. So we have our products tested to many different standards. I will not get into details to our products. So we have the former range, Hempa, the new range, sorry, Hempa Fire products, and the Hempa Core, that it was the first product that we launched. So Tarun and the rest of our colleagues can better explain you the products and tell you which is the right product for your project. What we want to highlight, it is the benefits of the range as a whole for you. So it's not only providing this high performance fire protection, but also to increase the efficiency of our products to your project. No? So we have products that they are durable and proven. We make good, we take a lot of care to make sure that the systems will provide the right protection with high durability and testing according to many international standards. We want to make your projects do not go high on the cost. So at the end, we are going to that efficiency in costs thanks to reducing the amount of paint that needs to be there, and also the labor costs that will be involved. The finish of the coating, because at the end, if we are choosing an Intumescent paint, it's because we want to have a good finish of the steel. It will be exposed to steel to make that the project shines as you have been thinking in the drawing board. We have our solutions have one product for all the steel sections, for all the profiles, in order to reduce the complexity and avoid that there are then mistakes during the construction phase. Sustainability of the products, we know that it is also a need for the buildings, and also we have it covered to provide credits to the green building standards and making available these waterborne solutions and reducing the carbon footprint in our products. Increasing the productivity of the paint process in order to make that the job will be completed faster, because at the end we want to help you to shorten those time frames that the buildings need to be done, and especially to overcome delays. So with this increased productivity and also having products that are easy to apply, that the painting process will not be a pain, that really helping you to keep the plant schedules. Going a bit into the detail of these benefits, just as mentioned, we test our products as systems, not as separate pieces, and we test them also in real exposure conditions in different parts of the world, and also in our laboratories. So we have both accelerated weathering tests with UV and cycles of salt spray and very humid conditions, something that can be reproducible. But then also in the real life, for instance, in some mountains in Germany, in Bochen, where in summer it can be sunny or very cloudy and humid. But then in the winter, as you can see here in the left, that it can be very cold. So our systems need to resist that. Then we have also in the roof of many of our factories, like in Poliña in Spain, also the panels there being tested, or locations like in Singapore, in order to assess the durability in these more demanding conditions, let's say high humidity and high temperature during the whole year, in order to make sure that the system will last in these conditions. The products are tested according to the different international standards, CE marking, the GOST system in Russia, Certifier or AP Plus Fire. And indeed, we have also all those certificates available. So it's not a product that we are doing an invention of our data. It's really third-party certified, and also annually having audits, rigorous audits about our products. Also, corrosion, it's being tested externally in order to make sure the compatibility of the systems or the emission of chemicals. Also, we have these external tests. Going to saving costs, this is a real example of an airport, Schiphol Airport in the Netherlands. This is because of the performance of the product. It allows to apply 20% less paint than with other manufacturers. And that provided not only the benefit of saving the amount of paint to be purchased, but also the amount of coats to be applied, and also the drying times in the construction process, and then also the speed of everything could be done. So that's also a case story that a customer was very happy. So you can find it also in our website, that the benefit to make the project going smoother, not only saving costs, but also helping in the project schedule. The static results, this is, as mentioned before, you are using steel because it's a good constructive element, and it allows you also to expose it and make nice structures. So then you need that it's coated with a system that it is to the level of your design. No? So we will need that there is no, there is the minimum orange peel possible, that there will be no overspray, that then will be just doing stains in the coating, and that it will give a roughness to the surface, that it will then take the dirt there. So in the service of the building, then it will look always dirty, just because there is that roughness that then makes difficult to clean. No? And also that the system that it's being applied, it can have a wide range of finishes, the texture, and also the colors for your project. No? That it's not like first cars delivered that it was only in black. So we allow you to do the color that you need for your project. Here in the left, there is
Rosa,
an
we
example.
are running end of the time, so if we can wind up in next couple of
okay,
minutes,
sorry,
please.
yes. So just a smooth finish in France, a restoration of a building. You can see the defined detail of the coating, what it was capable to be applied, and to enhance really the steel, how it was done 100 years ago. And here in the right, this is a shopping center in my hometown, where this is a hollow section having these you would need 4 people to embrace this big section. And if you can see that there is that roughness in the surface, so it's not to the level of the coating as we need. Going then, just making simple, so one product that can be used for any type of a steel section, so there will be no confusion if product A needed to be in the hollow sections and product B to the open ones. So the whole project can be specified, everything. Our products are suitable for concrete filled hollow sections, cellular beams, open or closed sections, so also avoiding that issues. Sustainability, our product contribute to LEED and BREEAM green building standards. They provide credits to these, and we have also certificates for the low emission of our products and the low VOC content. So we can help your project to get some of these points for these LEED and BREEAM projects. And then going fast, the productivity in the project. So our coatings can be applied in higher DFTs than other coatings. So it allows that the systems can be applied in less coats. So here we are showing an example that to protect a difficult stick section that it could require 4,500 microns. It can be applied just in 5 coats and 7 hours between each of the coats. So the PFP part, it could take just a little bit more than 1 day at 20 degrees. So we are able to protect a difficult steel section in 64 hours only in 5 coats for these C3 internal conditions that are quite demanding. While with other coatings, it could require 20% more time, but moreover also more coats, because the lower thickness that can be achieved in every coat need to apply. No? So it could mean that there is a 40% more times that there are workers there in the job site, preventing other parts of the project to go on, and also having more risk to have accidents or damages to the structures. No? And last but not least, just that it's Hempel is coming always very close from the painters. So we develop our products to be applied with a standard airless equipment. No need of a special pumps or complex 2-component or 3-component equipment that they can have problems of blocking at especially at temperatures above 20 degrees. No need of big crews or complicated application systems. So we want to provide a good quality finish in the first application, so to provide you at the end that there is no delays in the project due to the painting in the fire protection. So that could be the main goal from us. No? So in short, protecting it is just a system of different products to have these different roles. We will need then an estimation done, as David was mentioning before. We can provide this fire design to your projects. And then with these products, then we can also provide you those benefits. So, and with this, I want to give then the word to my colleague, Tarun. Thanks a lot. Tarun, the floor is yours.
Yeah, thanks, Roger. Good evening once again, everyone. I won't take much of time. I just want to say that in India, we are there from 2011, and our head office is located in Mumbai, and our factory is in Nashik. We are about 50 plus technical salespeople, plus around 17 plus coating inspectors, nation posted qualified, who ensures that coatings are applied correctly when you take an Hempel product. And just want to say that we are not far away from your requirement. We are here in India with their 4 regional offices and across sales and the service support to provide you the solutions. Thanks for joining. Thanks for your time.
Thank you to all the speakers. This is Anil Agrawal. May I take the questions now?
Mr. Anil, I think we have to take one question from Mr. Sridhar Reddy, one of the expert this thing.
Sure.
So can you
I would like to interrupt you for a moment. We have an announcement from Andrea. So if you just quickly, Andrea, can you quickly do the announcement, and then you can take forward for the panel discussion.
Yes.
Yeah, thank you.
Please can you stop screen sharing? Thank you. Okay, I request all the attendees to please participate in the poll and subscribe to our YouTube channel, SCS TV. Do glance through our latest interactive issue of SSMB magazine, which is focused on special structures. The issue takes you through the cover story, which is a majestic and pierced structure, that depicts the creativity of Indian project team. So do have a look. To keep you hooked through the magazine, we have our special segments, Mind Bogglers, which brings your screens a novel idea and tales, which is sure to inspire you and yet another renowned structural consultant's journey. The link to the same will be available in the chat box. Also, do write your feedback to edit@mxbm.in. Thank you. Over to you, Mr. Anil and Mr. Anand.
Anandji, so maybe we can take that first question that you were talking about first.
Yeah, we requested Mr. Sridhar Reddy question first. Anil sir, can you take up Sridhar Reddy question first? He is our eminent expert panel.
Yeah, I have not. I don't have that particular question with me. I'm not sure. If you have the question, you can.
Teddy, if you could, yeah. Sir, could you please put on your camera? We can see you.
All the panelists, can you please switch on your cameras? All the presenter.
Yeah, Mr. Reddy, Sridhar Reddy ji, if you have the question, you can, if you are available here, you can ask the question directly.
Yeah, yeah. Good evening. This was a very knowledge sharing session. Thank you very much for your contribution, Mr. Roger and the team. So my question is, if at all I have to get a proper drawing, I have to submit the structural drawings to you.
So, so the question is that if we have a structure, we have the structural drawings, and we want to know what kind of fire protection to provide, can we send you, and would you provide the support in terms of fire protection designing? If you share with you the design and drawings.
Yes, I might comment on that. So we receive different files for projects. We can receive lists of the steel elements, either in Excel, in PDF, and we would tend to find that's a quicker way for us to process that information. Structural drawings help us understand where those profiles are, but it takes a long time to be able to get you the quantities out of those drawings. So the best is we get lists of the profiles as well as the drawings to marry those two things together. But yes, we do take that information, and our estimation teams are there to process that information and provide the best intumescent coating systems for those projects. But additionally to the drawings and the material lists, we would also like to be provided with what the fire duration is, and if known, the critical temperatures, but if not, we can provide you prescriptive values as we do if we don't know. But we would need to know the sort of end use environment so we can get you the right coating for the end use environment for the project. And I think that's also something our local sales reps could also assist with.
Yeah.
Thank you. Thanks, David. So just extending on that question, I have basically summarized all the questions that we have received from the audience. And many of those questions are asked by several people. So I'll not be able to announce the names of the people who have asked the questions. So extending on that same question, now, say for example, for India, we don't have any many prevalent codes which can be used for intumescent coating. So coating. So what should we do in India? Which codes to follow? Where do we get the guidance in terms of fire load and all the way translating that information into the intumescent coating thickness?
But the fundamentals, wherever you are, remain the same on the section factor. Section factor is sort of a universal concept around the globe, so that would remain the same depending which product you're using. In terms of the fire durations, again, it depends which design code has been used to design the structure. That should have the guidance on how you develop the fire resistance period. And in terms of temperature, again, it depends which design code has been used to design the steel. And I know that, say, BS 5950, the British standards, have that well documented. Also, the Euro codes have that well documented. But also I believe the Indian standards, I think it's IS 800, also gives some guidance on critical temperatures. But if not known, I think what's been used prescriptively in India and most of Southeast Asia as well is this concept of 620 for three-sided beams, degrees C, and 550 degrees for columns. And I think reviews I have done of particularly the Indian design code and the British standard codes, those temperatures would be applicable if you knew nothing about the structure.
Okay. Yeah, thank you. So basically what you are saying is that as long as I know the critical temperature, which might be available in some Indian codes, which are actually, and also if I know the utilization ratio, then from these two informations, I can marry the two and I can use your manuals to decide the thickness requirement for the coating, right?
If you calculated a temperature, then you can simply use that temperature with the actual thicknesses we have presented. It's presented in a way that allows you to use multi-temperature and multi-section factor. Okay. So you're able to do that. But if the calculations seem unknown or it's not known, Hempel are happy to assist in those conversations and help actually do that work and try to determine the temperatures as well.
Okay. So now, in addition to that, we also have these legal requirements of fire protection. So what kind of legal framework is available in India to support? So for example, for most of the designs, we have to use one of the Indian codes, which is a legal document, which works as a legal foundation. For intumescent paint, our IS 800 or the other fire safety guidelines are not sufficient. So what is it that designers can fall back on and say that this thickness will be sufficient? What is your experience with the design projects in India?
There are international design codes that could be reviewed, but in terms of best practice, I think those on the call would agree, the ASFP, the Association of Specialist Fire Protection, has much guidance on best practice, specification of intumescence, and have a lot of documentation that could aid if those documents don't exist within India. So I would really recommend looking at the ASFP. Which I think we'd be happy to share. And it gives a lot of really good guidance on intumescence and other fire protection materials.
Okay, great. Now there are several questions on the durability and lifespan of this intumescent coating that you supply. So can you give us some kind of a, is there any warranty on different kind of climate conditions? I saw several slides where you had presented that you have proven that this coating works in very tough conditions, very corrosive conditions also. But do you have any kind of a warranty or anything on the performance of, as far as life expectancy, the chip-off resistance, or corrosion resistance, these parameters are concerned?
Correct. Yes. As you saw the pictures, no, that this is something that it's tested intensively. The durability, it depends also in what it is, the ambient conditions that it's being used. If you remember, there was a picture in the left, no, showing exposure in the mountains where it was sunny and then foggy, and then it was in the middle of in the winter with all that the snow and ice, and those conditions are more demanding than what it will be in the indoor of a building. Oh yeah, a protected structure inside of the building. The conditions are much less demanding. So then the durability of the coating system using the same pieces, let's say, it goes extended. So all the paint manufacturers that have ETA, so ETAs, the ETA of that we have for our products, for those extreme conditions that we were showing in the snow and in the mountain, it's already at least 10 years endorsed already by those third-party certifications with the tests and the standards that are being done there. And then it allows us that for depending on the conditions of your project, the service conditions of your building, then it's extended. No? So what we do it is that we do not say blindly a timeline, but just that we look what are the conditions of your project, and for interior of the buildings, in what we've normally we find generally it can be lifetime of the building. It means that we need to select the right coating combination. So if we would be using, depending on the products, then it could be less, but if it is needed the lifetime of the building with the proper maintenance and the proper conditions, it can be there. Yeah.
Okay. Thank you. I think that answers the question. And another addition to this in the same context is this primer application. So this primer is also supplied by your brand itself, right? So that primer has to be used with this particular coating. Is that correct? And do I need any specialized equipment or specialized manpower to apply these coats, or the entire service is provided by you only? How does it work?
The primers, we test better our systems. So it could be also that there are some cases that the primer is already applied on the steel. So we find cases that there is from another manufacturer, and we have tested the compatibility with many of them, especially the ones that we know at the end that chemically are similar to ours, and we know their behavior. But it's true that from our products, we control if there is any change in the formula. So if some value engineering is done by another manufacturer, we don't know it. So maybe we tested something 2 months ago, and now there is a change there. That's why that we recommend our systems, that we really know this compatibility. And the testings are always done with that. And the equipment to be applied, it's not any special equipment other than standard paint. So primers are very easy to apply. It's low viscosity paint. It's easy. It can be done by automatic machines, or also things that are done with manual equipment. That's
also the painters don't need any special training for application.
Well, you need some training. One thing it is that you don't need a PhD or something, that you don't need to be really highly skilled people, that then it's difficult to find, and also the salary grades are high, but it's a life-saving product. So even applying primers and top coats, so it's if somebody knows how to apply a primer and a top coat, it will be then very easy that we can explain the few tricks that you need with the PFP. Application equipment, it can be the same or really very similar. So you don't need a PFP, but okay, You need to take some care.
If I may contribute,
like any other coating, yeah.
If I may contribute to that, there is no need for a specific training, but Hempel does provide some trainings for our customers, and also via our coating advisors, there is normally is guidance given to our clients. So this is also a service that is available from Hempel, and I think that's worth mentioning.
Yeah, Professor Jayachandran has asked a couple of questions. I think I'll give them the priority. So he has asked that if there is a fire accident already in a building which was protected with your coating, then what would be the process of refurbishing the building with another coat after the fire accident? You had shown a picture of one building which had undergone a fire accident. Then how do you coat it again? What will be the process?
What would be necessary in such situation is that all the material that has reacted, that needs to be removed. And first of all, of course, first a verification needs to be made if the steel structure is still okay. Is it still capable at carrying its load? But assuming that that's the case, then all the reacted material needs to be removed. And in most of the cases, in reality, it will be that the entire coating system needs to be removed. And then you need to clean the steel up to SA 2.5, maybe by high pressure water jetting. That can be an alternative. And then you need to build up the system as normal. If you have a very small fire and only the outer side of the intumescent coating has reacted, then you need to remove the reacted material, and then you can build on the system where it is still sound.
Thank you. Also, if the coating is already applied on a structure and I want to assess whether the coating has sufficient thickness or not, how do we do that? What is the process for that?
Normally, the electronic thickness gauges are used for that. So it's a common tool used in the coating industry, and then you can just measure thicknesses. And there is acceptance criteria created that we can also provide to you if you would prefer, to see if you're in line with the specification.
Okay. Also, it was mentioned that usually when we specify our requirements, we specify number of hours of fire resistance. But usually we do not mention what kind of fuel will create that kind of a fire resistance. So is there any kind of a database available at your end where I can do an assessment for my building or my compartment or my house and see what kind of fuel or what kind of fire load I have available in my house? And based on that, I can do a more performance-based kind of a fire resistance, fire protection design. This question is again from Professor Jayachandran.
Well, there is not a very specific split. If you have, for example, wood or textile, that all is covered for cellulosic fire protection. If there is chemicals that burn way hotter, such as petrol or maybe chemicals or oil, then you need hydrocarbon fire protection. But for the rest, I'm not aware that there is a list of different types of fuel. It is all things that are commonly used in civil buildings. There you would need cellulosic fire protection.
Yeah, so that answers the question about the type of fuel. Also, the amount of fuel also is an important parameter. So, of course, there are international codes as well as Indian codes which say that if the building has this utilization, this kind of a purpose, based on that you can decide how long the fire will be. But is there any other guideline which will help us directly calculate that?
That is a question that I think David can probably contribute on.
Yes, I'm not aware of, it might exist. I'm not sure about the Indian design codes, but certainly I can discuss this from a Eurocode perspective. There are methods of being able to calculate the real fire that you would expect. When we talk about resistance, we don't talk about the development of the fire from ignition to develop. We don't talk about flashover, and then how long the fuel actually takes to burn out in the decay phase. There are methods of calculating this in the Eurocode, which are for smaller compartments, but it's quite a difficult process. You have to know the ventilation conditions, the actual fuel, how quickly that fire develops. So there's a lot of parameters that go into calculating how long these fires would actually burn. And that's why typically people refer to just tables that say, how high is your building? 90 minutes, done.
Yes.
So it is absolutely possible. And you can use equivalency to then say, well, that's my real fire. This would be the fire resistance period. But that is real fire engineering. Fire engineers would have to do that work and really understand the design of the building. And I think if that work was to be done, that has to be done very much at the design stage. But there are certainly codes available in Europe that allow that. I think there are certainly others that have those calculations, but they're not easy.
Correct. Yeah. Okay. Thank you. So now the biggest question that I think has been a common thread in the number of questions that I have received, that is basically the cost comparison with other options. So people are asking questions about how does the weight compare with other options, other fire protection options, and mostly they are concerned about other passive fire protection options such as cementitious spray applied material or the gypsum board. So in comparison to those, how does the weight compare and how does the cost compare? If somebody can take up that question, please.
Okay, I will go. I think that's a tough one. I think obviously you can see from the presentation that the intumescent coatings are very lightweight. Looks like a decorative system. Okay, the thickness is a little bit higher. But as you compare to cementitious, as you compare to fireboard, for me, that will really vary job to job, depending on the fire resistance required. We know, for instance, the fireboards maybe start at, I don't know, 60, 70 millimeters. They can go up to 120 millimeters, depending on the fire rating required. And same with cementitious. So I think that's only something what could be really evaluated on a job by project basis.
Okay. So in your experience, because you must have served various types of clients, typical buildings, let's say from various heights, can you give us some estimate of what percentage of structural cost goes into fire protection, passive fire protection, approximately from this range to that range, if you can give a range?
As Scott had mentioned, a very difficult question. And I'm not sure if this is correct, but I had seen some reports issued by the SCI, I believe, the Institution of Structural Engineers in the UK, where they looked at this. And I think the cost, depending on your fire duration, between 10, maybe 30% of the steel package cost could be fire protection. But again, it's such a difficult question to quantify. How much does it cost? Because it's on so many variables. But don't quote me on that, but I'm pretty sure there have been studies done at the full cost of fire protection, steel and other elements, and that should be available online somewhere, and maybe we can find that and share it.
Okay, so I think most of the major questions are taken care of so far. One question one gentleman was asking was that what is the minimum steel thickness for which your catalogs are available, for which we can do the calculation for the required protection. So is there any limit to how thin the sections can be or how thick the sections can be for which you can apply this fire protection?
I'll give it a try. It's also, again, it's a quite difficult question. This is very much depending on the product. And it's also very much depending on what type of steel is used. Are we talking about an I section or a H section beam, for example, or are we talking about a hollow section? So let's take a hollow section as an example. The wall thickness of a hollow section, you can say that needs to be in the approximate thickness of 4 millimeters, and then there's a large amount of products that can provide protection. Maybe not all products, and some others can go even slightly lower, but that's more or less the minimum wall thickness of the steel that can be protected.
Just to add to that, Eric, as well, I think when you look at steel thickness, I think the purpose of intumescent coating is to protect the structural integrity of the building. And when we start talking of steel at 2 millimeters, 3 millimeters, we've really got to try and understand, is that profile, is that piece of steel integral to the structural integrity of the building as well?
Okay, yeah, that makes sense. Any examples of using this kind of a material on cold form steel, which is typically galvanized already?
So your cold formed steel, typically that'll be elements such as your purlins, cladding rails, your really light elements. But
yes,
but as Scott had just mentioned, when we're talking about the stability of a structure, and those elements don't actually pay any contribution to the actual structural stability of a building. It's not considered a primary element. So if we were to remove those cold form elements, the building would probably still remain standing.
But the purpose of fire resistance system is not only the overall stability, but also to provide containment to fire. So if the floor system, for example, or roof system collapses, so even though it may not risk the entire building's stability, but it will lead the fire to spread to other compartments. So at least to that extent, we need the fire resistance.
Yes, and then we're talking about compartmentation and how we actually contain the fire. And particularly if we talk about purlin, say in a portal frame structure, we're more interested in making sure that the walls stay intact, but the roof perhaps not. There is guidance on actually dealing with these elements as secondary elements. So although they're not primary elements, you can protect them by limiting the section factor and providing a thickness, but this is really to prevent heat transfer into primary elements because they're not really part of the main structure
okay.
The stability.
Yeah.
So
okay. Yeah, one more question I'll take. That will be last question from my side. So far, I don't think I have any other questions. Basically, when we asked the question of durability, that was primarily from the causes of element, but also we may have issues of large deformations in the structure, or also there may be some accidental loading. For example, if you have a column and the column has corners and there is a 3 millimeter or 4 millimeter thick layer of intumescent paint, over a period of time, that layer can get chipped off because of the people's movement, vehicle movement, or any trolley movement, so on. So those kind of chip off and those kind of issues, are there any tests available for them? Similarly, let's say there is a beam which has large deformation, maybe because of earthquake or just live loads, large deformations could happen. And for those, there can be some damage to the intumescent coating. So is there any kind of a testing that is done for the elasticity or the durability or the toughness of the coating?
Well, I'm not quite sure if I 100% understand, but I assume that you say there is deformation in a certain element, and you are asking if the intumescent coating can follow that that type of deformation. Well, an intumescent coating, this for the cellulosic fire protection, the ones that were subject in today's presentations, is a thermoplastic coating, and it is way more flexible than the steel element. So it has a low tendency of cracking once it's applied in the correct manner because of its thermoplastic nature. If you're talking about mechanical damage where material could be chipped off, that is a different story. It can definitely be damaged by impact, and I think in all the maintenance procedures, it will be mentioned that if a damage has occurred, then it requires repair. So it will be necessary to regularly inspect the intumescent coating if such repair would be needed.
Okay, so mostly intumescent coating is only available in white color, or there are other color options as well?
It's available in white, but it can be top coated in any color. So
okay. So yeah, so that can be a sign of that damage. So if you have top coated it with a different color, and then you can very easily identify that there is a chipping of the
correct.
Okay, so Anand Saab, I think I'm done. Most of the questions are covered. One request I have received from several audience members is that the YouTube link for this meeting should be shared, so that because so much of information was shared in a very short period. So
I think Carol will take up this particular point, and
yes, so we will share the YouTube link. Yeah, sure.
Okay. So thank you from my side. Please, I think Carol will take
a few questions more were coming, like what is on-site testing and all those possibility of it, if anybody want to take up the question. On-site testing and as well as the corrosion protection by the fireproof coating. If anybody want to take quick question on the time.
Again, I'm not sure. Again, I'm not sure if I fully understand the question. Correct. On-site testing we do at several locations. We make testing in order to have experience in different corrosion environments. And that is basically in order to check if we are comfortable in supporting certain conditions. But that will all be done before we enable certain exposure in for a certain product. So after the product has been launched by Hempel, then there is generally not much more environmental testing done, unless it may be for an approval, and then there is normally artificial weathering tests. And yes, we are running some tests on request sometimes. Yes, that is normally for getting certain local approvals.
I think that's it from us. And I think one more thing which we wanted to add up, the fire or Agni in Hindi has been the one of the major development in human history. 1500 year BC was discovered, and from there the major development of human has happened. And earlier it was considered as a friend, protector, and now we are looking to save it from the fire. So with this, I will hand over to the organizer, and thank you very much to all panelists and knowledge sharing. Wonderful experience. Thank you, Anil, for wonderful questions. Carol, over to you.
Thank you so much to all the panelists, the moderators for joining us and making the session a successful one. Requesting all the attendees to please subscribe to our YouTube channel, SCS TV, to get updated to today's recording as well as all other webinar recordings and steel construction update. Do join us next week on 14th October at 4:30 p.m. for our upcoming webinar, and write to us with feedback at edit@mxpm.com. Thank you so much. Have a great evening.